Hello class, and today we are learning about stress-strain relationships. So, when you're thinking about stress, it is a force that is applied to an object.
Strain is how the object changes shape because of what happens to stress. So with strain here is since you have a force applied, it's either going to increase or decrease its shape.
Does the class have any questions? You, right there.
Can I see a graph?
Yes, you can. Okay, so she is drawing the graph. Okay. So this is the stress and this is the strain. As you increase stress, you should increase strain to make the object or whatever you are focusing on more compliant. Compliance equals strain, by the way. Science. So if you have a certain amount of stress applied, and there's so much stress that you reach the failure point, that is where the injury occurs in a joint or whatever object happens, or if something breaks, the failure point is where the breaking or the injury is going to happen. The plastic region is the region on the graph where there is only temporary deformation. So that means that when the object is changing shape, it'll only temporarily change its shape due to the applied stress. On the other hand, the plastic region is when there's permanent deformation. So if you think about it, if something bends a certain amount and then there's a permanent bend, so if this is what you're bending and you bend it this way or whatever, if afterwards it stays like this, that means it reached the plastic region because it didn't originally go back to this shape. It messed up.
So I think I understand the stress-strain relationship, but I don't understand how it relates to athletic injuries.
Okay, that's a really good question. So according to a peer-reviewed article that I actually read, it was on sports specialization in high school students. And so what it actually said is there's a higher lower extremity injury, mainly in a lot of your tendons and your ligaments. If they specialize in a certain sport, they have a higher risk of obtaining those injuries.
I think I'm still having trouble understanding. Is there maybe an example of like a sport injury, like with soccer?
I completely understand. So how I relate it to soccer, I played soccer for quite a few years as well in college. And so the best way to explain it would be an ACL tear, so your anterior cruciate ligament. So if you think about it, when you make a cut in soccer, like if you're going to make a pass or things like that, you have to stop first on your leg. So let's see how I can draw this really quickly. So here's let's say that's your femur, and then here's your tibia. And so what's happening when you're making, and here's your foot. So what's happening when you're making that direct stop, your tibia is wanting to go this way, and your femur is stabilizing that and making sure that it kind of goes here. But what holds that there is your ACL ligament in here. And so when you tear that, you're putting too much stress on the tibia when you're making that direct stop, to where your tibia keeps going forward because that ACL ligament is too much stress on it, to where the strain becomes too much, to where it hits that plastic region.
Hey Maggie, since you've been on your phone the whole time, can you please explain what we've just been explaining for the last million hours?
I only care if it relates to rap music.
Okay, talking about rap music as in Kanye West or Eminem's?
Nah, Dr. Dre's my homie.
Well, don't you worry, because I've got a rap song for you about stress-strain relationship.
What up, Detroit? Yo, what up, Detroit?
Today you're gonna learn about stress and strain, how too much stress can cause some pain. Stress is the force applied to an object. Too much stress on the joint, it'll get wrecked. There's a force applied which causes deformation, but when there's more strain, it'll make a transformation of the object. It'll change its form, which will help your joint from being torn. If you have a lot of stress on the joint, you'll need to get more compliant. That's the point. The more stress, the less compliant. Be careful to your joints or you'll end up like Kobe Bryant. So with too much stress, injury to the joint. When injury happens, you reach the failure point. In the plastic region, you'll have permanent deformation. In the elastic region, it's just temporary deformation. So the real takeaway from all this information, being more compliant yields a better transformation. You increase compliance by increasing strain. Now take that info and lodge it in your brain.
In your brain, in your brain, in your brain, in your brain, in your brain.
Lodge it in your brain. Lodge it in your brain. Lodge it in your brain. In your brain.
Alright, class, so what did you guys learn? Maggie, did you learn anything from that rap?
Yes, I actually learned that stress is a force applied on an object, and the more stress increases the strain on an object, and it can get into the plastic region, which then this object will break. And when it gets to the plastic region, it could cause injury when it reaches a failure point.
Good job, Max. I'm proud of you. Class, did you guys learn anything else?
Yeah, I understand the elastic region more now, because if we're able to stay within that region, then we run less risk of reaching the failure point and less risk of injury because our body's more compliant.
Okay, class, I am extremely proud of you. You have learned stress and strain so well. We have got you to learn stress, forces applied, and strain, the change of shape, and you guys did a fantastic job. We incorporated rap music and even graphs on the whiteboard. Great job, and have a nice day. Boom.